Hey everyone, welcome back to another math video. Today we're going to be solving linear equations. Now the equations that we do today are going to be a little bit more complex than the one-step and two-step equations we've previously done in other videos. So if you haven't watched those, you might want to check those out first before checking this video out. But if you're comfortable with those two, then you're good to go and we're ready to solve these problems. So let's go ahead and let's get started. The problems that we do today are going to be mainly similar to two-step equations. Some of them are actually, and the only difference is that we have to do a few more steps before we turn them into a two-step equation. So for example, on this first one, I can see that this problem has a couple of like terms. So I can see that this 7m and this negative 9m, both of these are like terms because they have the same variable and they were both raised to the same exponent power, which in this case is 1. So I can actually combine these two. I can do this 7m and this negative 9m. Together that will get me a negative 2m. I also have here a negative 4 and a negative 36. And these two can combine and get me a negative 40. And the 0 on the other side of the equation or equal sign will stay the same. So here now I have a two-step equation. It's just that I had to combine some like terms first. The first thing we're going to do for this two-step equation is we are going to add 40 to both sides. That will leave me with a negative 2m on the left side. The 40s cancel out. And then 0 plus 40 is just 40. Next thing I want to do, I have a negative 2m here, which is a multiplication that's happening between a negative 2 and an m, so I'm going to go ahead and divide by negative 2. Dividing by negative 2 will leave me with m on the left side. The 2's cancel out, and 40 divided by negative 2 is just negative 20. So m equals negative 20 is my answer for this first one. Again, throughout these problems, if you feel like you need to pause and go at a slower pace, rewind, by all means do so. Go at your own pace. I'm going to go ahead and move on to the next example problem. Here we're going to use something that's known as the distributive property. What the distributive property is, it's basically we take the number that's outside of a set of parentheses and we multiply everything that's inside of those set of parentheses by the number that's on the outside. So here I can take this 10 and multiply it to the 5 and multiply it to the n. Whenever we have a number outside of a set of parentheses, it means we got to multiply that number by whatever's inside of the parentheses. This is called the distributive property. So that is the distributive property. It's just we got to share the multiplication. So if I do 10 times 5, all right, so first thing I'm going to do is I'm going to do 10 times 5. That'll get me 50. Then I do 10 times this negative n, which gets me negative 10n. The negative 1's going to stay the same, and also the 29. So next thing I want to do here is I see that I have a pair of like terms. This 50 is a constant and so is this negative 1. I can actually combine those two. Combining those two, 50 minus 1 is simply 49. So 49 minus 10n equals 29. Okay? So just combining those got me a 49. Now what I want to do, I have another two-step equation now, so I can subtract 49 from both sides. That'll leave me with negative 10n equals, if I combine a 49 and a negative 49 and a positive 29, that simply leaves me with a negative 20. So now all I have to do to solve this one, I'm going to go ahead and move it towards the right. So negative 10n equals negative 20. I can divide by negative 10 on both sides. And that'll leave me with n equal to negative 20 divided by negative 10, that is simply 2. So 2 will be our final answer for this one. Okay, so in this problem we get introduced to the distributive property. After we distribute, we can then combine like terms, and then we have a two-step problem. Okay, let's go ahead and let's do some more examples. We're going to go into the next problem. Here we have a fraction in front of our variable. So we want to learn, how do we get rid of this 1/2? Okay, well, the first thing I'm actually going to do for this problem is I'm going to get rid of the 2 first. I'm going to isolate it. I'm trying to isolate the x. So I start doing that by first removing the 2. So I'm going to subtract 2 from both sides. I'll have 1/2 x. These 2's cancel out. This is going to equal 1 minus 2 is simply negative 1. Now, how do I move a fraction like this that's in front of my variable? Well, in order to remove a fraction like this, we multiply by its inverse. So in case you forgot what an inverse of a fraction is, the inverse of a fraction is simply that fraction reverse. Okay, so I flip the fraction upside down and I multiply by this on both sides. So I'm going to multiply both sides by 2/1. Okay, what we'll see is that the 2's cancel out and we're left with 1x, because the 1's, everything simplifies to 1. So technically I'm left with 1x. But normally when you only have 1, you don't really write it as a coefficient. It's the same thing as me just stating x. So we've actually already isolated x by doing this. Negative 1 times 2/1. Well, that simply turns into negative 2/1, which is just negative 2. And that's how we get rid of a fraction that's attached to the variable. Okay? So once again, if you feel like you need to pause and rewind, by all means go ahead. We're going to move on to another example. Here we see that we have a fraction outside of a set of parentheses. Now there's two things we could do. The first one is we could distribute and multiply everything inside of the parentheses by this 1/5. Or we can actually get rid of the 1/5 first, which is what we're going to do. So I'm going to go ahead. I'm going to rewrite this so I can have a little bit more room. Have 1/5 times k minus 3 equals 3/4. Now what I'm going to do is I'm going to multiply both sides again. All I'm going to do is I'm going to flip this fraction upside down. I'm going to multiply by that. So I'm going to multiply both sides by 5/1. This in turn cancels out that fraction. So I'm left with k minus 3. Which now I don't even need the parentheses since there's nothing outside of them. It's going to equal, multiplying these two fractions, again for multiplying fractions, multiply the numerators by each other and then the denominators by each other. So 3 times 5 is 15, 4 times 1 is simply 4. Now I have to try to remove this 3. So I can remove it by adding 3 to both sides. I get k, because these 3's cancel out, equals, I'm going to say 3 plus 15/4. And we want to try to simplify this a bit. So what we're going to do is we're going to turn this 3 into a fraction. So I'm going to multiply. I want the denominator to be 4. So we're going to move this over here again to the right so we can have more space. I got k equals 3 plus 15/4. This 3, if I wanted to have a denominator of 4, I need to multiply it by 4/4. And it's actually, I can write it as 3/1. So multiplying this out, I get 12 over 4. Okay, so that means k, we're going to substitute 12 over 4 for 3. K is equal to 12 over 4 plus 15 over 4, and that equals 27 over 4. So I can leave my answer like that if I want, 27 over 4, or I can rewrite it as 4 3/4. Okay, if I want to simplify it. So that would be my final answer for this one. Okay, let's go ahead and let's continue to move forward to our next problem. Now this one seems a little bit more complicated because now I have two fractions and m is actually on top of each of those fractions. So there's numerous ways on how to solve this. The way I'm going to show you is going to be to first we're going to want to combine these two. Now in order to do that, I need to get these denominators to match, which means I'm going to have to multiply this fraction by some number in order to make the 4 into a 12. So I know that 4 times 3 is 12, so I'm going to multiply this whole first fraction. So I'm first going to convert this fraction. I'm going to convert 3m over 4, because in math, if I'm multiplying by 3 over 3, it's the same as if I multiplied by 1. So I'm allowed to do this. 3m times 3, again, numerator times the numerator, that leaves us with 9m. Thinking of the denominator. 4 times 3 is 12. So this is the new fraction that we're going to use, and we're going to substitute. Okay, so now instead of having this original problem, substituting 3m for 9n over m over 12, we're going to get 9m, I'll write it in blue. So this is our new problem, 9m over 12 minus m over 12 equals 7 over 8. Now we can actually combine the 9m over 12 minus m over 12. 9 minus 1m. So 9m minus an m will leave us with 8m over 12 equals 7/8. Now again, I'm going to move it over to the right for more space. So I have 8m over 12 equals 7/8. Now the next thing we're going to do here, similar to how we get rid of a fraction in the previous problems that we've done, we're going to multiply by the inverse fraction. So we're going to multiply by 12 over 8. Okay, this will make the 12s cancel. It'll also make the 8s cancel, leaving us with just n. But we also have to multiply the other side by 12 over 8. Okay. So multiplying this out, I can simplify here a little bit. These two are divisible by 4, so I would have 2 over 3. Alright, so 7 times 3 would get me 21. 2 times 8 is 16. So my answer is 21 over 16. Now let's say you didn't know that this 12 and this 8 could simplify if I left them as they were. Okay, and if I just multiplied 7 times 12, 7 times 12 is 84. Sorry, I'll write that in black. 84. 8 times 8 is 64. This would still simplify. I can keep dividing this and I'd end up getting 21 over 16. Okay? So again, I find it easier to simplify first, but if you forget and you just don't know how to simplify, or you forgot how to simplify, you can divide both of these by 4 in order to get 21 over 6. Okay, because 81 divided by 4 is 21. 84 divided by 4 is 21, and 64 divided by 4 is 16. Okay, so that's how we got our answer. Final answer being m equals 21 over 16. Let's go ahead and let's do one more. Here's our last problem, which involves decimals. So let's go ahead and take a look and see how this one's going to work out. First thing I'm going to do, this is just a normal two-step problem, so I'm going to have subtract 0.68 first from both sides, leaving me with 1.2n equal to, now you don't have to know how to do these in your head, you can use a calculator. Obviously, if you did it using a calculator, you would get 4.32. Next thing I would do, I would divide by 1.2 on both sides. That would leave me with n equals, here I should get, if I do this correctly, 3.6. So hopefully these examples have helped you out, and now you understand linear equations just a little bit more. I will say this isn't the only way. The ways I showed aren't the only ways to solve these problems. There's definitely other ways. These are just the ways I showed you. I'm not even going to go so far as to say that these are the best and the easiest ways, but to others, you might find another way easier. And if there's another way that's easier for you, by all means, go for it. These are just suggestions on some ways on how to solve these problems. There's definitely more than one way to do it. I hope these videos have helped. Thanks for watching, and I'll see you guys next time in another video.